Okay, recording. So we're going to be creating a to-do app in Druid today. If you are new to Druid, this is going to be from like just nothing and you'll learn everything. If you've watched my other video on Druid, then this will just teach you more of the tools that you need to use Druid. First, we're going to initialize our project. So let's go into Rust and we're going to go into, what do I call this? Druid tutorial, yes. And we're going to create a new binary project and we're going to call this to-do tutorial. Right, so now we've created our to-do tutorial and let's open, oh, we need to go into the directory first. And now let's open our cargo.toml because of course we're going to need some dependencies, right? For a to-do app, we're going to need some things, right? Of course, we're going to need our UI toolkit, which is going to be Druid. We're also going to need a way to save stuff, which is going to be Surday. In Druid, it's based off of like data. So everything is based off of the data for the app, right? Everything reacts to the data being updated, which is why Druid's like core motto is it's a data-oriented UI toolkit for Rust. So we're going to need to create our app state, how the data is actually structured. Then we're going to need to that is going to go into Druid, and then we're going to need to create the basic design of the UI, and then there's other stuff we're going to have to do like theming, which you can skip of course, but if you want a theme, you can learn how to theme, stuff like that, right? Let's start off with what we need. So first off, we're going to need Druid itself. So let's go get Druid. I'm going to get the latest version. This is all, oh my god. Hold up a sec. If you want to know why I was excited, I haven't realized this used to say version 0.7. We're now in version 0.82, 0.8.2, 0.8.2. I was using this before because this was just nicer than 0.7, because 0.7 was not nice to work with in my opinion. I didn't expect this update. Okay, that's just crazy. So, instead of adding the GitHub, we're just going to add the 0.8.2 version, which is, okay, that's just not expect that to happen. Okay, back on with what we are doing. For this, for the data, since we need to store everything, we don't know how many items are going to be in a to-do list, right? That's just determined by the user. And we need to make a way for this to be easily clonable, because all data in Druid has to be easily clonable or just very cheap to clone, because if it's not, this data is being passed through the entire app. If it's not easily clonable, that's just not good, right? And if something's not easily clonable, you would probably want to replace it or wrap it in an RC. And for that reason, instead of using a vec or an array, which wouldn't really be nice to work with, we're going to work with this vectors from this crate called I'm. So we're going to include a feature over here. So features equal crate code I'm, right? This crate just allows us to have nice and easy way to have easily clonable listed data. And I'm also going to add I'm directly. Crates wants to load at some point. There we go. There you go. And we're also going to need Surday, of course, to save our data. We're also going to need Surday JSON, because we are going to save this in JSON. If you want to save it in something else, go ahead. It might be a nice challenge to not exactly follow this tutorial and maybe I don't know, use YAML if you wanted to. I don't know why you'd want to, but you could use the YAML, for example, toml, all of those sort of files, right? So for what I'm doing right now is I'm adding a feature flag to Surday because we want to just use the derive macro. So we're going to add the derive feature to Surday. That way we don't have to do extra work, right? And our life is just easy. And I'm going to add another crate called directories. And this is just so that we know where to like actually save the config file or like your save data, because you don't just want it to be in any random directory, right? You don't want it to be in their home folder cluttering it up, or using like, because it's like if you want other people to use it, it's nice to have it in the correct location, and this correct location can be determined with directories. So yeah, those are our dependencies, and we're just gonna cargo build. That way Rust Analyzer can actually like know what we're using, and you know, this part is just long. Okay, now that we have everything nice and done, let's go into our main file. Actually, first we're gonna set up some sort of like actual structure for this app before we get devolved into chaos. We're gonna want a UI.rs, and this UI.rs we're gonna also just include it over here. And we're also gonna want our data.rs, just where we're gonna store our app state. And also save this one. Mod data. There we go. And let's just let's go to your UI, and let's start off with writing just a basic shell. That way we actually have, you know, something up and running. So let's create a function for this, and we're just going to call it UI builder. And this has to return anything that implements a widget, right? In Druid, everything is just like you return one type of, oh, why did it do that? Don't do that. In Druid, when you everything is just described by one widget, and usually how you handle that, right, is you use a container widget like Flex, which is like a Flexbox or like a Z-Stack, stuff like that. Let's just make this a U64 for now, right? So now we have that. Let's just create a window that just says like hello or something. Literally just return a label. New. Actually, let's go with the closure approach, because I just want to show how that works. We can, oh, we're not going to use that, right? Okay, that's fine. We're just going to just straight up just say hello world. You can use closures and labels to like use the data inside of your label. It's mad at me and I want to know why. Cargo build implements widget. Oh, I should have realized we did not actually import anything. Wow. I'm just gonna unmerge use because that looks ugly. Anyways, so we have this label, and what we're gonna do is we're gonna set up our main function. And for that, we're gonna need to, let's make our window descriptor first, right? So we have our main window and I love my spelling. Window description new, and we have to pass in our UI builder function, UI underscore builder, and let's title the app over here hello world. No, let's actually name it my to-do app for now, even though this isn't really a to-do app, it's just hello world. And do we really need a set window size? Sure, let's go with the window size for now. Let's go 400 by 400. All of these do need to be, we're putting it in a tuple because it only accepts one thing, anything that becomes a size, and tuples become sizes, like tuples implement the into for that, and it needs to be of f64, right? It has to be a floating point, so we're just using the dot there, right? And there we go. So that's our window descriptor done. And then let's just call our app launcher. So app launcher just launches the app. Yeah, it's kind of explanatory. Window descriptor is like the description of your window, like what is it, how does it look like, right? Like what's the title, is it transparent, stuff like that. Your app launcher is where you just start everything. So let's launch. And we have a U64. We're not using that right now because we're never going to use that actually. And we're gonna use expect because this can return an error. But if it returns an error, that means our app doesn't work. So why would you handle it? You don't really need to handle it. If you were making something that you wanted to ship to people, you might want to actually handle it, put like a nice message. But for now, it doesn't really matter. I'm just going to say fail to start. And if we run this, we should get a window. If we don't, then I forgot something. And that's very sad. Hello world, let's go. If you're thinking that this kind of looks ugly, we're going to theme it later on. It's going to be cool. This app is going to go through a transformation from this simple hello world. What we're going to do first is we need to make like our actual data structure. So let's make a pub struct, right? Just a public struct, and we're going to call it to-do state. This is going to be our main level, like the main data for our entire app. And if we think about it, only thing we really need in here is just a list of all the to-do items. So we're gonna make a field called to-dos. You can name it whatever you want. I'm just gonna call it to-dos for now. We're gonna use the vector, not vector, and we're gonna use it on something called to-do item, which doesn't exist yet. And now let's actually create that to-do item struct. And the reason we're doing it like this is because our app data, the main app data, is just going to be like what we have as to-do items. And each to-do item is going to be described by this, right? And we're going to use a list which goes through all of the things in the vector and uses the to-do item for all of this. So what do we need in a to-do item? Because a to-do item is just like the actual to-do thing in our list, right? In our to-do app. We need two things, right? We need both whether it's like done or not, like whether the user checked the box or not, and we also need the text that's actually displayed. So I'm gonna make something called pub checked, or you can name it done, which might be better. It doesn't really matter, and we can also make another one which is a string. Cool. Right now these can't be used in our application, right? We've defined our data, but we can't use it in our application. So what we need to do is we need to derive some things. So let's derive. We need clone because in Druid everything needs to be cheap to clone. That way it goes with the whole since this data is being passed around, because it's all like data oriented. The data is being passed around everywhere through the app. We need this to be easily clonable, cheaply clonable. So we need clone. That's why we're using vector, by the way. And we also need data, or data, or data, and lens. There you go. Why? Oh, there you go. I realize. It's because to-do item doesn't have that. Yeah, I was going to get to that. Anyways, to-do item also needs to have these derived. Otherwise, the derives for the other things can't work. So let's do clone over here, and let's do data, and let's do this one. If you don't know what lens is, we're going to get to it. Lens is important for this project, and you'll see why. It's an important topic in Druid, like just generally when you're working with it. It's kind of complex, not really, but just a little bit. We're going to get to that though, just not now, because I don't want to explain it right now. I'd rather show with examples. Okay, so we have our data. Now let's actually put it into our app. So right now we're using, if we go back to UI Builder, we're using anything that shoots back a U64. We need something that has a to-do state, right? And we need to go back over here because that's not going to be nice. Can I just do something really easy over here? Default, and over here default, because I clicked U by accident. Let's just put default, that way I don't have to initialize anything. There we go. Then we do to-do state. Ooh. and we're gonna just use default. That works. Nice. Okay, so we're just gonna launch it with the default data, and right now we're not gonna use it. We're just gonna test if this runs. And compiling. There we go. So app's still not a to-do app. Not surprising. Let's go on to making. What do we need? We probably want to make like the basic design, right? So what is this basic design gonna look like? If you can design this however you want, but my idea for this is you have your text input over here, and then you have a button that just submits that, and then you just have your to-do list with ... and you probably want like a clear button somewhere, like I don't know, in the corner. You just have the clear completed button, and we're gonna just do that. That's gonna be the basic structure for our app. And so what we need first is, I'm just gonna return an empty flex box for now. Flex, what do? We want to do a flex column, right? Okay, I confuse column and row sometimes, but basically we need a flex column because we need just like a row. Wait, we need a flex column because we want a list of, when we want a top header, then we want the bottom list, and then yeah. So that's just what we need, right? And we need to import this because otherwise it doesn't know that that exists. We don't need to remove the label because we're going to actually use that label later. So let's create the header. How do we create a header? Simple. We're going to make two widgets. So let's create our header. This is going to be a flex row. So for our header, we're going to use a flex row. And with that flex row, we're going to add a child. Right? So dot with child. This doesn't take anything, right? Am I being stupid? No, yeah. So we want to do with child, and what's our child going to be? We're going to want a text box. Text box. Oh my god, there's so many things that use text. Wow. Okay, text box. And we're going to use new to create a text box. However, we run into a problem right now because text box needs a string. It mutates a string in your app data constantly. So basically we need to add something to our app data that handles that, right? So for to-do state, we don't only need to-dos, we also need a way to do text. So let's just call it new text. Why not? New text. That's going to be a string. And this is where a lens come into use, right? Because if we look at this, our to-do state is made of two fields, but our text box only wants a string. We're giving it a vector and a string, and it doesn't know how to use that. So what we do is we do a dot lens, right? To-do state colon, and now we're going to use the lens for new text. This is our derived lens, and basically this just makes it so that text box actually knows what it's using and doing. So there we go. If we type stuff in the text box, it's going to update that variable. I'm going to put that semicolon there, and I'm going to move this to the next line because just to look nicer. And we're also going to do another child. We're going to make this one just going to be a button, new, and I'm just going to use just a text arrow just to, make it a submit button. We don't want to say submit this. I think that's a bit clunky. I think we're fine with this. We're actually going to add the onClick later because it's a little bit more complicated. Yeah. Also, one thing we do want to do is that this text box, let's run it just to see. Oh, hold up. I forgot to add it to the flex that we returned, so we were just running nothing. But width, child header. There we go. It's not going to take up the entire space. That doesn't look that great. We probably want it to take up the entire space, right? So there's something called, if we're just going to put it onto the end over here, called dot expand width. Yeah, we want to expand width. Because we want to like make it take up the entire width. The only problem with this is with a flexbox, it doesn't know its constraints. So it's infinite. And it just doesn't render. So that's a problem. How do we fix this? We use a thing called with flexchild. What is a flexchild? No, it's not Phil Spencer. It just basically allows us to add a constraint. We're just going to do one dot. Literally any number I put in here gives me the same result. I don't know what it means. I just know that this number is like technically the size that it can use. But yeah, if we run this now, we should get a nicer looking header bar. There we go. Look at that nice header bar. If we expand it, it expands. So beautiful. We can type in text here. Hello text. Wow. We have this nice little bit of text over here. I'm sure you can read it for yourself. We have this nice bit of text over here, you know, just another to-do that you can add to your own list. Yeah, okay. But right now, that doesn't do anything. And it's not going to do anything because I want to go into something else. Because if you do use the button, we're not going to see anything for now. So we need another thing. We need basically our list of to-dos. And we're just going to call this to-dos. Why not? And this is going to be a list. Lists are very fun and a little bit confusing. So basically when you make a list, right, you see it says closures. That's the argument that you need to put in. And what is this closure? It just basically runs through every single thing in an array that you give it, and it just uses that, and you can build whatever widgets that this closure returns goes into your list, and it just populates the list. Every time the data is changed, it'll, like every time a new member is added to the data it's using, it'll actually update. And for that, we're giving it right now it's a to-do state, right? That's what it's inferring its type is. This is a list, the curly brace, list angle bracket, to-do state, angle bracket. But that's not what to-dos wants. That's not what list wants. List wants like an actual, like just an array, right? Just like with text box, which just wanted text. We need to do another lens on this one. So let's call this to-do state, right? To-do state, and now we're going to need to use to-dos. Wow, look at that. And now it's going to give us a little bit of anger, and I don't actually know why. It's not implemented for blank. Huh, okay. I'm just going to add this to the bottom over here with child to-dos. And I'm guessing this is because we're not returning anything yet. But that's fine. We're going to return stuff very soon. So for this list, we need a flex row because we want like certain things on this row. So what do we want? We need, first off, let's actually just design this in comments right now. So what we need a checkbox, right? We need a checkbox. That's my best attempt at a checkmark, guys. And then after that, we're probably gonna want the text itself, and somewhere off into the distance we're gonna have our like context menu that we use to delete or something, right? If you want to add other stuff to that context menu, like whatever. So right now we want to add a checkbox new, and this is where the lens on to do item comes back, because if you remember, we have lens on to do item, not just to do state. And there's a reason for that, because every item in this list is using the type of to do item, because that's what like the value like of every item in the list. it goes through every item in that list and gives it to whatever in the closure. And basically, checkbox doesn't like a string and a boolean. We just want a boolean, right? So let's do checked. Do I need to import this? Why does it not like me? Oh yeah, why does it not like me? Oh, because I didn't. Right, so checkboxes can take in the string value. The only problem with that is that I want the checkbox on one side, like on the left side, not on the right side. And if I wanted to do spacing of any kind, it's more annoying, right? So I'm just going to use a blank checkbox, and then we're going to do another child. Actually, what I'm going to do is we're going to go over here. There you go. I'm going to add another child, and this one is going to be this is going to be just a label. Oh, so we do actually need the closure, right? I totally forgot about this. So basically, if you want a label to update to certain data, you're going to need to use a closure in it, and that closure will just become, like, that closure is just the data, right? So what this closure takes in is going to be your data, which is going to be and to do. Actually, I think this is going to be and string, because we can use a lens for this, right? And we're going to have we're just going to have that because we don't care about what our environment. We're not going to use it. And hold up, I'm just going to do .lens to do item text. Yes. So now we should just be using like the string data, right? And all we need to do over here is just return that data. And that's going to be mad at us probably because this needs to be a mute string, if I remember correctly. Is not for implemented for argster. Well, that's annoying. Okay, I'm just gonna remove this lens because I don't know what that's saying and I don't want to figure out because I'm too lazy to. We're just gonna use a to-do item because it's not that complicated. Text clone. There you go. It's probably mad that because, you know, strings, I can't just like, they're not clonable. Like they are clonable. They don't implement copy on them though. So it doesn't want to like give away the reference. It can't move that out. We'll do the button for the like the context menu later because context menus really deserve their own time. Right now, let's get something into this list, right? The best way to do that is probably going to be to allow the user to type in something. So let's create an onClick method. What does this onClick method do for us? OnClick. This just allows us to like actually submit the data. If you want to like make enter, like if you want to use it so that when you press enter on the text box, it'll also submit the data, you will get to that. There's a way to do that. It's just a little bit more involved and takes more time, and we'll do that later near the end because, you know, it's just too complex for now. We're just setting up the basic structure of our app for now. So for this onClick, right, what we want to do is first we need like the actual like the arguments that the closure takes in, which is going to be our context, which we're not using because we're not sending any sort of we're not sending any commands. We have to have our actual data, and we have to have our env. We don't care about our env at all because we're not using anything in that. Okay, first we want to check if it's empty, because if it's empty, we don't want to submit. Like if someone like clicks submit or clicks enter on data that's just like nothing or just space, you're just gonna put a to-do list item that's just a space or nothing. Is that really what you want? That's probably like no one probably wants that, right? So we're just not gonna make that possible. So we're gonna test if the new text, and we're gonna .trim. That way if they put like an accidental space, it doesn't matter. we're going to test that if it's not equal to blank string, right? Then let's actually get into what we want to do, which is we want to just clone the text because we're moving text out of the we're moving text outside of the closure again. We only have the reference to it. That reference is not going to live that long. So we're going to clone that again, right? Then we're going to set our data.newText, right, to blank. This basically just clears, so like after they submit, it doesn't keep what they have there anymore. It clears it, which is probably what you expect, right? And we want this to be to_string because that was a string. We didn't use the answer. We did use a string. And now we're going to do the fun part. Data.todos dot push front or push back, whatever you want. I'm going to use push front for now. And we're going to make a new to-do item. Right, and that's going to be false at the beginning, because if you just submitted something to a to-do list, you don't want that to be already checked. That doesn't make any sense. And then we're going to use our text. Actually, since we did name that variable text, we don't need to do :text, because Rust can infer that. Now, if we did code this right, or if I coded this right, we should be able to insert stuff into the list, and it should work. So let's go. Hello. Code today. I love that. Don't you love when you're just typing and you're typing so fast that you can't let go of shift fast enough? Yeah. Create programming tutorial. We'll all get to that. Honestly, I kind of want the checkbox after. Or do I? I'll keep it like this for now, because I think this is good. Like, this looks nice. Yeah, so let's just keep it like that. That's cool, right? So that's good. We can actually add things to this list. The only thing is, it's gonna spam a bit. We can't see what's after. Like, if the list gets too long, then, we can't see unless we wanted to expand the app. But let's say we go past your screen resolution. What are you going to do? Buy a second monitor? No. We're going to do something. We're going to just fix it for them, like here. Yeah, we're just not going to make that, like, an error that possibly can happen. We're just going to use .scroll. The only thing with .scroll is we're just adding this as a child. And if you remember, flex boxes, they don't have constraints. Like, the children don't have constraints, right? So they just think they can expand infinitely, which means it'll never scroll because it never thinks it's out of view. So we add a flex child. Yeah. Okay. Now this will actually scroll if it gets too long, and let's check that out. Look at that. Yo, we can scroll. That's so cool. That actually worked first try. Did not expect that, honestly. I thought something was gonna go wrong at this point. Okay, so what do we need next? We've made our list, and we've made our, like, the way for this to, be, what am I saying? We made the list, and we made our header, so we can input data into the to-do list. I guess that's the basic structure of our app done. We have, the basic design. Not everything in a to-do list is there, but a lot of it is, so that's cool. Next, we're gonna actually make this into a functioning app. Let's start off with the ability to remove things. So to remove things, we need a way to notify that we want to remove this item, right? What's the best way to do that? We're gonna add a button to every single to-do, and that button is just gonna be used for just saying clear this thing. However, if you want to add other stuff, I don't know, if you want to keep track of when you implemented implemented. When you inputted a to-do, if you want to keep track of that, show that with the user with like, I don't know, properties menu or something. You don't want to keep like adding buttons. So I'm just going to add like a dot 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 button, kind of hide away some of the stuff. So we're going to add another child. And we're going to call this child, this is going to be a button. And we're going to use the text dot dot dot. Right? Doesn't do anything yet. That's fine. If we want a list to appear, we need to use a thing called a context menu. Now, context menus are kind of confusing, right? So let's create an on-click menu, on-click function first. So we have that. We have. Oh, actually, this is a time when we actually do need CTX or context, because the context lets us actually show the menu. We're gonna have our data, which is gonna be and mute to do state, and the reason to do item, and that's because, you know, in this list, in the closure, everything has to do item, right? And then after that, we're not gonna actually need our environment at all, so that doesn't matter. Yeah. So why is it mad? Oh, it's because I forgot the okay. Let's go. So what we want to do is we're going to do ctx dot. What's the function called? I should probably annotate it so that it knows what I'm using specifically. And I think it's no, it's just end context, right? Event context, event ctx. There you go. Show context menu. So the context menu has two things. We have both our location and our menu. We're gonna create the menu really shortly. I just want to deal with this whole I did not want to do that. I don't. Why does it pain me like this? Okay, that's why. Okay, there we go. New X and Y, let's do 0.0. This just makes it so it appears on the button. Now this menu, where are we gonna make this menu? We're just gonna make it in the closure, right? So we're gonna let our menu equal menu, use that, and all we're gonna do is, oh right, okay, so menus need to be of the type of the data type of the root application, right? So they can't be of type to do item, because that's not the type of them, like the main application. That's to do state. So we do need to specify that this is to do state, because it infers that it's to do item, and it doesn't like that. Does not like that at all. And then what we need to do is we're gonna make a menu that's empty. Menu empty, and then we're just gonna add a with. It's not a with child, it's a menu item, right? What was this function called? Oh, dot entry. Okay. I just had a brain fart. Okay, so basically we do need an entry for this, which is going to be a menu item, if I remember correctly, right? We need a menu item, and that menu item is basically what we click on, and I'm just going to call this remove, right? And each menu item has its own on-click like thing, but it's on activate. So every time you activate it, it's going to just run this closure. It's kind of like on-click. So what we need to do is we're going to have we don't care about that first argument at all. Then we're going to need our inner data, which is inner. That's a bad name. It's just like main data. And that's going to be and mute to do state. And we're also going to, we don't care about our environment again. That's cool. So now we have a menu item. When we activate it, we want to like find out where. We need to find out like where in the like list we are, and we need to remove ourselves, right? And it's kind of nice that it kind of worked out like this, because for our to-do state, we have the vector of all the items, and in the button, we have the actual item itself. And I just realized this is going to be slightly painful if we do it like this, for the sole reason that, oh, that is not, why does that not want to play nice? I want to move this in over here. There we go. That spacing is wacky as all hell. There we go. So now, the reason I moved it into this closure is because I don't want it to scream at me, and there's no reason for me to move it into this closure if I can just have it in the closure and just define it over here. So basically on our entry, what we need to do is we need to find the location. So this is the reason I didn't call it data, because we have both data and main data inside of the closure. So we have data, main data. If they were named the same thing, that'd be confusing. So basically we need to find our location, which is just going to be equal to main data dot to-dos dot index of, and we just want to find data. I just need to check. This takes an AND reference. Yeah. That takes an AND reference. And this wants to be me, and I don't know why. But we're just going to unwrap this. There you go. Why is this not compiling? Right. Wait, hold up. Oh, okay, yeah. I forgot about this. So, to be able to remove stuff and to find like the position of stuff, we do need to know, like, we need to be able to like check for equality. So we're just going to add partial equality and equality. Right? And that just lets us do this easily. And it's screaming at me again because it takes ownership of data. Use the move keyword. Okay, so basically since we moved data into here, we just need to do move. It's still being mean. Let's do a little bit of trickery. And we're gonna just, in over here, we're just gonna, since data should be easily clonable, cheap to clone, we're just gonna call it data. We're gonna make a data clone. That way we have like data.clone. And we're gonna use data.clone. That way it doesn't scream at us that the lifetimes don't match up. There we go. That fixes that error. We now have the location. It shouldn't give us a none ever. Because if it gave us a none, that means that it doesn't exist, which means it was removed already. But that means they couldn't have called it, because if the to-do item is removed, then you can't see the button, because that to-do item doesn't show up at all. So I'm not going to match for that. You can do like error handling. This is just a simple to-do up, man. Then let's just do main data. Actually, you know, just main data dot remove. Why did it? Oh, dot to-dos dot remove location. That should just work. If you did want to like just error handle, I guess you could just like take away the unwrap and then do like if let some location or index equals the location, something like that, you know, whatever. That should let us remove stuff, and we're gonna check that right now, and if it does, that's gonna be really cool that it worked. Let's go. Right now, I'd say that the to-do area doesn't look that nice. I'm going to just improve that right now. Because in our list, what we can do, it's kind of getting a little bit ugly, but it's fine. We can take this button. After it's created, we just do dot align to the right. Align right. Yeah, there you go. That should make it so that it's on to one side and the other stuff is to the other side. If not, then there's like a simple way to fix that, right? Yeah, okay. Okay, so we don't want to do align right. That's not going to work because we have, I just realized that wouldn't work. So basically it's not going to work because if we do align right and align like left on this, they're just gonna center, or just gonna go to one side. What we really want to do is we want to add a flex spacer. Oh no, flex spacer with flex spacer. I'm gonna use 0.1, but I literally think it doesn't matter. And if we add an item, it should just work out. Why did that happen there? If you want to know why that broke, it's because, so a scroll box, I think, allows for basically infinite, like, width or height, right? And it'll scroll in both directions, so it thought it could just, like, put it to infinity, and you can just scroll to infinity. That's why there was a scroll bar, and I was super confused, because there shouldn't have been a scroll bar. Adding vertical just basically means that it can't go beyond the constraints of, like, the sides, right, the left or right. The list can only go, like, down, right? So that shouldn't happen. So now that, like, that thing shouldn't happen, if we run it, if we, like, just input something, yeah, there we go. We have our item over here. We can remove it. If we add 2 items, let's check. If we remove this one, it just removes that one, right? And it just works. Let's go. Okay, so remember that vertical, or else you're gonna spend like 10 minutes debugging like I did. Yeah, don't do that part. We have a remove button. Let's add a clear completed button now, because I feel like that would be nice to have, right? If we have like a bunch of tasks that are like checked off, like, oh, we're done with these, and we want to clear them, instead of going and removing everything, let's just add a way to do that. We're going to do that with something called a Z-stack, because I want this button to be floating above everything. I don't think that Z-stack allows me to, what up? You know, the base layer. Yeah, okay. So yeah, so our base layer is going to be this, and then we're going to add dot width. Oh, hold up. Dot width. We don't want a child. Let's use align child. And this is going to be a button. New clear completed. And this is, okay, this is actually kind of getting a little bit messy. I'm going to remove this from over here. Let's just make something called a clear complete button. And for this, we can do on click over here. And this on click, we don't need that. We do need our data, however. And we don't need that. Okay. So basically for this closure, all we need to do is we need to basically remove everything that's been checked, right? And to do that, we're just going to use the retain function for vectors. And retain basically just has a closure that runs for every element and just checks whether that thing matches the criteria. If it matches the criteria, we keep it. If it doesn't, we don't. So, easy way to do this is going to be data.todos.retain. We're going to have our item over here, and basically not item.checked. That should just work, right? And for over here, we're going to use a unit point because we want to center this in a way, and we're going to do bottom right because I want it on the bottom right. And before we run this, actually no, we're going to run this and I'm going to tell you why I'm going to add padding. So if we run this and give it a sec, our button's in this corner, which looks really nice, right? The only problem is I can't click some of these buttons, especially this last one. I can't clear this one. So we fix that. for me is really easy. We just add a padding, new, and we're just gonna like give like, I don't know, 5 all around. That seems like a nice number. It's not happy because that padding has to come first, I'm pretty sure. There you go. Yeah, so for padding, the widget comes afterwards, which I kind of find weird compared to everything else, but it's fine. Now you have like this nice little padding, which just looks really cool, right? Now if we just I'm just gonna shrink this down. A dot a dot a dot a. Oh, look at that. You can technically you can't really press that, but it's fine. Feels like you can, and that's all that matters right now. Yeah, there we go. Why can't you press it? That's kind of wacky. Whatever. It just, you can see the remove button at least. If you increase the padding, you might actually be able to see it. So yeah, there's that. If you think about it, we really are almost done with our app, because all we really have left to do is saving and theming. Which is kind of insane if you think about it. We've gone from 0 to something. We're almost at like a full to-do app. Let's add saving before we go on to theming, because I think saving is more important than how nice your app looks. Honestly, I'm gonna create a new file for this. Let's call it saver. Let's not call it saver, we have to call it saver.rs. And I'm gonna save that, go into here, main.rs mod saver. There we go. So for our saver, right, we need something that basically every time our data gets changed in a meaningful way, we save it to somewhere, right? And the best way to do this is to create a widget, which you might have to do a lot. So creating custom widgets is another important part of Druid. And the reason we're going to use a custom widget for this is because custom widgets have to handle updates to data. And we can handle that in whatever custom way we want. Let's do a saver, pub struct saver. And basically all you need for any sort of widget that you create is you need to do, of course you need to do your struct, right? But then you just have to implement widget for everything. So widget on whatever data. I'm just going to use to-do state because of course we know what we're going to use. We don't have to do generics. And we implement this on saver. And it's going to scream at us. Why? Oh, because we don't have. And it's going to scream at us. Why? Because we don't have our missing members. Wow. So we don't care about event. We don't care about lifecycle. We don't care about layout. And we don't care about paint. Oh. Okay, we actually do need to give a layout of some size. I'm just going to do 0.0. Okay. However, what we do care about, right? We do care about updates. Okay, hold up. I'm just gonna... Okay, so I've just gone ahead and put underscores and everything we're not gonna use because I don't like the warning messages. They just clutter everything. So for our update, first we want to check if the update's because of our text box, because if you remember, our text box updates new text and the new text field every time someone types anything or deletes anything, which we don't want. So first we're going to do is if data dot new text. No, we want to do it on to-dos, right? Yeah, I don't know why. So we need to check if our to-dos is we need to make sure that the to-dos are actually different, right? Because otherwise that means our new text is updated, which is not what we want. We don't care about new text being updated. There's no reason to save any of that. So what we need to do now is basically every time that we know that actual data has changed, we need to find out where we can save, and then we have to save. So let's do if let sum If you don't know what I'm doing right now, that's fine. But I'm just going to type it out real quick. Okay, so basically what I've typed out over here is we're taking our base directory, right? So basters is what we're using to find out where we can save stuff. We're finding their config home, and then we're just going to save it over there. So basters, we need to initialize it so that it can actually find out where in the system that we can save to. So we make a new basters, but sometimes it can give us a null value. So we have to do, let's just do if let. If you don't have an actual config home, then I don't care. I'm not gonna deal with that. You can probably make some sort of failsafe. I'm not gonna do that right now. We create the config. We're gonna format the config. We create the config, right? So basically, we take the config directory, make it into a str, because this is a path, right? So we make it into a string, unwrap it if it fails, and then there you have where we can save to. And we're just gonna add a slash, and then myTodo.json, right? That's where we're gonna save stuff to. That's our config path. Well, technically that's a config string, not our config path. We're gonna actually make a config path, which is just gonna be the same thing, but it's a path. Path new and config. Let's import this. Now, one thing we need to do is we actually need to be able, we need to like describe our data somehow. So for that, we're just gonna make a new class, right? We're gonna make a new struct. And this struct is just gonna be called task data. The reason I'm making it, the reason I'm not just like putting in like to-do state itself is because we don't need new text, and also if you want to add other like sorts of, like if you want to add like light mode, dark mode to your thing, like that's separate from system, and you want to have like separate configuration in that file, you can of course do that. We're just going to do pub tasks, and this is going to be a just a vec, not a vector, because vector doesn't implement serialize or serialize or deserialize. And yeah, that's also another reason for doing this. And what we're going to do is we're going to derive stuff. So let's derive serialize and deserialize. It's going to scream at us because we don't actually have a... Oh, nope. So I see what was wrong. Basically what happened is it was trying to serialize, but it doesn't know how to serialize to do item, right? And since to do item doesn't already derive or implement serialize or deserialize, it was just getting mad at me. So the easy fix for that is basically just to add serialize and deserialize over here, right? Adding them just makes this work now. That's nice. Right now, since we know what we want to save, right, it's going to be really easy. So what we do is we're going to create a variable, just call it tasks for now. And we're just going to create a new task data. Why is this pub and the rest of this is not pub? Actually, no. It doesn't need to be. Yes, make pub. We're just going to make a new task, right? And this is going to be, or we're going to make a new task data struct, right? Just an instance of task data. And our tasks are going to be our data dot to-dos dot clone. That's going to be like what we want to like store. So we need to take our to-dos and we're going to put them into task data. We're going to serialize that into a string, and we're going to write that to the target file, myTodo.json. Now the only thing is, if you haven't noticed, this thing isn't actually a vec, it's a vector. And to get around that, we're just going to do this thing called into iter, and we're going to do collect. Because make our lives easier. I don't know if this is fast or not. I don't really care. This was just the easiest solution I could find out. I just clone it, make it into an iter. If I just use dot iter, it doesn't work for me. But if I do .into iter and then collect it, it just works. And now we have our task. Now all we need to do is, let's use fs. Does it want to? There we go. And we're just going to write to the file. So we're going to write to config path. And we're going to write out tasks. It's probably going to want us to... No, why doesn't it? Oh, right. I see why. We need to actually serialize this. I forgot about that part. So serde JSON dot to underscore string. Yeah, to underscore string. Use and tasks. And we're gonna unwrap this because that should just work, and I'm not gonna handle that for now. And we're just gonna expect that if this fails, that means that the full the full path doesn't exist, right? Which means that their config home doesn't exist, which shouldn't happen. So we're just gonna say config path does not fully exist. We can write our data to this file now, right? And it actually will probably work. The only thing is we can't read it back, so it doesn't really matter. So for that, we're going to create a function called readStored. It's going to be public because we're going to use it in main, and it's going to just be called readStored. And this is going to return task data. Right, that way, like the main function, we can handle that, and we can use that as our default launch data. So in readStored, we're going to have a little bit of boilerplate, right? Because we need to find out where their config home is again, and then we need to get the path. Easiest way to do that is just copy it from what we've written before. There we go. And we're going to let our data equal match. We're going to just read to string, right? Our config path. And basically, oh, why did I do that? There you go. So basically, we want to read to the file. If we can't read to the file for whatever reason, we're gonna just return nothing, right? Because we need to return something. We can't just crash the program if they're... So the main reason we're doing that is because if they don't have if the thing isn't if the data is corrupted, we just don't want to crash. That doesn't make any sense. So what we need to do, I'm gonna actually return the error to them at the end. But basically, let's just eprint at first that their config home is their config file is corrupted. So the saved data is corrupted or no longer. Oh no, wait, no. Right, hold up. So if I just realized I was thinking ahead to what we're gonna do next. So basically, we're gonna do two things. So if we can't read it to a string, that means it doesn't exist, right? If it doesn't exist, we don't want to crash the program. All we want to do is just return a default task data. So we're just going to return a default task data, right? Return a task data, which is just task vec new. So this is basically just saying if we can't read the data to string, that means it's either we corrupted in a way we can't read it, or it doesn't exist. If it doesn't exist, that means that this is probably the first time we open the application. So we don't want to crash on the first time, because that way we will never ever actually get to open the application, right? So we have to return something over here. We don't want to crash, and then we want to do something else, which is we need to basically we need to deserialize this data, right? So we're going to do another match, and we're going to do serde JSON from stir, and And we're going to take our data, and with that, I'm going to fill in match arms. So basically, if in fact we do get the data, we are just going to return it, because if we serialize it into the format, then we're done, right? We've successfully serialized our data into task data. Nice. If we couldn't, that means that there's something wrong with the formatting of whatever, of like the data that we read, right? Whatever data we read. So we're going to just doeprintln, because this is an error. The save data was, or is corrupted, or no longer in the format it should be in. Error E. Oh. E. My Python brain got to me for a bit. And we're just going to return an empty task data. I should really just implement default, but I'm too lazy to now. And we need to return task data on all things. We can't just not return task data, because, you know, we specify that we're going to return task data, but we're in an if statement right now. So we're just going to return an empty task data. For the else statement of this block, we're just going to return an empty task data, because that's all we need. There we go. So basically, okay, why? Oh, I forgot to put the semicolon over there. I see. For this one, we don't actually need the error. I just realized because I was not thinking properly. Yeah, there we go. So now we have our task data. For tasks, we have that. So if we, right now we're not going to read anything back, because in our main file we don't actually read anything. So let's actually go do that, right? So after we create our file descriptor, right? Or file descriptor, window descriptor, let's just make a variable called cat stored. Let stored equal read stored. Right, that should always return us something. And then we're just gonna make our default state. We're just gonna make that equal to a task state, to do state, and our to-dos are gonna come from store.todo or store.tasks. And then our new text is just going to be blank, right? Can I do .default? Is that a thing? No. Oh. That works. Okay. Remember how we're using a vector for to-dos? We need to make a vector. So let's do vector from there we go. And now we need a semicolon over here, and instead of just launching the default, let's just launch default state, right? So default state. This default state should contain everything. Let's run this application. So the reason there's stuff in here is because I did make a config file already. So that's where these come from. If we do check all of these, except hey, our clear completed does work. You can do remove. If you write subscribe to for meh content, we can do like and share. You know, stuff like that. This is so funny to me. I just love this. And then we can just clear those, and then we're done. And if we do keep them, we should be able to Right, it doesn't save. Okay, so the reason this happened is because I forgot something really important. So we actually do need to include our widget somewhere, or else it's not going to know what's happening because it's not involved in any sort of data. So in the header, because our header is we're just going to put everything in header. Why not? So if we do with child, this thing literally takes up 0 space, so it doesn't matter where we put it. I'm going to do saver. There we go. This should be a saver, and this takes in 0 arguments. There we go. So let's just put in saver here. This takes in 0 arguments. It doesn't matter. We're gonna have data here. Let's remove that, right? These random test datas. Hello, my name is John. That's not my name. And that's not a task either. I need to code. My actual name is Walter White. And we need to cook Jesse. So, those are all of our to-dos for today. We're going to close the app. Let's say we completed some of those, right? Let's say we cooked today, right? Like we cooked today and we coded today, right? So we can clear those out. And look at that. If you didn't realize, those just saved after we closed the app. Our to-do app is now functionally complete. Let's go. The only thing that we don't have is, I'm going to run the app again, is if you saw, I have to keep clicking this button. I can click enter on my keyboard. I can't click that button, which is really annoying. But there's a way around that. And this is another thing in Druid you might come across. It's called the controller. And a controller is basically just a class that you use to intercept certain like inputs, right? Let's say like if you have like an input, you don't want to make a new widget just to like do the input. If you just want like if you have a widget, you just want to like somehow like intercept like 1 or 2 inputs, controller is probably what you want. So at the bottom of this app, we're just going to create a struct called enter. This is going to be our controller. So basically, to make a controller, we want to make a struct called, we're just going to call this enter, and then we're going to implement something on it. So for this, we need a generic because we don't want to specify the entire line of widgets that it takes. It doesn't matter what the widget is. We just need the widget to take in to-do state. It's a to-do state. And then we're going to implement controller. And that's going to take in 2 generics. So that's going to take in to-do state is going to be the T generic or, you know, the type generic. And then we just need W for this. And we're going to do that for enter. So right now we just need to implement our default members of from controller. We care about event. We don't care about lifecycle and we don't care about update for now. So all we need to do, right, is go over here and then let's just add stuff here, right? So if let event key, I think my LSP died. I'm not gonna lie, that's kind of sad. Anyways, so what I'm doing here is I'm just trying to get like, so we have like a event, right? So this event is like what event like came to like the widget that we're having, and we're intercepting it right now, right? But we don't know what the event is. We only want events that are of a key up because you can have multiple key down events on a key down. You'll only ever have one key up, so that's just nicer. And then we're just gonna set that equal to, so if let event key up key equals event, right? That means we have our event. Then if the key code, right, if the code for that key is Oh, I'm gonna enter if it's enter. Then all we need to do is check if our data is not null, which I'm just gonna steal from up here. Where is that? You see this? We can just straight up steal that, because we're basically just doing the same exact function, right? So I need to import Druid.event. Why is it being mad here? Okay, it's being mad at me, so we have to import that. Then to add that equal sign that I forgot. Okay, so now basically all this does is if we have an event that's a key up and we just take the key code, if it's enter, that means we can run whatever is run the script that we use to actually insert stuff into to-dos, right? And then this is really important because you really need this, right? Don't forget this, because if you do, that's going to be painful for you because you're going to be debugging for hours, right? You need child.event ctx event data env. The reason you need this is because if we intercept every signal that goes to the thing, that means every key press, we intercept every key press that we put into the text box. And if we don't pass on the event, that means that you will never type anything, right? So you probably want that if you want to be able to type things into the thing. So now, if we check this, hello. Oh, okay, I see what I did. We do need to add this to our our text box. If we go back to our header, find our text box, and then we do dot controller, we use event. Oh, we use enter, that's what it's called, right? Now we should be able to do something really fun. Hi, enter key works. Now your app is complete. You both have your submit button and enter key works. The only thing left is that you might notice that this app looks bad. Like, I'm not gonna lie, these dark buttons not doing it for me, right? Everything else is okay, like the GTK3 styling, like whatever, right? That's gonna be different depending on your system. These buttons, not it for me. And just like the general style of the app. So we're gonna get on to styling now. So first thing in styling we want to do, I do want our the to-do list area to be darker, right? So all we have to do is come up to over here, right, in our thing, for every single item. Actually, right before that, we're gonna implement a color. RGBA 8. The reason I'm using RGBA 8 is because I don't want to set a color right now. Like, I don't want to think of what colors will look nice. I'm literally just gonna set it to black, and then I'm just gonna add transparency. That way it's just darker than the rest of the app. And I don't have to set primary, whatever, I don't have to do that, right? I'm gonna set this to 50 because I think 100 is too high. And then we're gonna call this nice method, it's just called background. And I'm just gonna do BG, right? All this does is background takes in anything that becomes a background brush, which can be a color, which is nice. And we're just going to set the color to 0, but only 50% transparency. It's just going to be darker than everything else. Also, well, yeah, let's run that first. Let's see how that looks. Nice. This actually kind of looks kind of nice, right? If you, oh, that enters so nice. Look at that. You have your area that's not your text, and then as you add text, it becomes dark, right? You have your nice scroll over here. Everything is kind of cool. But these buttons still look bad. Everything else I'm fine with. These buttons just look bad. So what do we do about the buttons? Well, we have to go to our main file, actually. So in main, there's something you can do with your app launcher before you start it, right? all we have to do is we have to do dot set env, or configure env, right? And this takes in both your env and your underscore state, which you don't care about. And so to explain what I'm doing, dot configure env just like configures your environment at the start, so you can like set keys. Keys are this thing in Druid which I've not used yet, but basically they allow you to set values for things that you can take in later places, right? But basically we're just going to use this because there's something that you might not have, like, that took me very long to find. It might have taken you very long to find. Basically, let's go back to here. Let's open the docs.rs for a sec. It's gonna open. Okay, there you go. So oh, right, that's why. Hold up, Druid. Here we go. So if we go to the docs.rs, right? You may be like, there's nothing on theming here. There is. There's a bunch of keys on theming, right? And all these keys are used to like set specific stuff. Like this background dark. I'm gonna use like button dark and button light. So what we do is you have to do env.set and you take in your key. So let's do button dark, and we're gonna set that to a color value. You can technically make a function for this instead of using a closure, put that in its own thing so your main file is nicer. I'm just gonna do it here because I'm just like adding two things, and I don't think it warrants having a different file, you know, making a function. I think it's just nice enough to do that. So we have our button dark. We're going to take color. We're going to do RGB A8. And from here, we're going to do 100, 100, 120, 0. Oh, that's so weird. Okay, I didn't even realize that. Okay. I do have like some of these like colors set on a separate window that you can't see. And I just realized that I set that to 0, so it doesn't matter at all. I don't know why I did that. Color RGBA 8. And we're going to set this one, oh, hold up, semicolon. We're going to set this one to 100, 100, 100, 100. Right. Now, if we run this app, we should see something really cool happen. Oh, there's so many things in here. AR button. No, that scroll bar. I'm gonna change that scroll bar at some point. Anyways, this button's kind of transparent. If you can see, you can actually see through it, which I think is kind of cool for like a floating button. Also, all these buttons are like lighter color. I'm gonna like remove all of these A's because they're driving me insane. There you go. Yeah, so all the buttons are like just a bit lighter. And also you can set your window background color to a color also. I'm just gonna set it to RGBA8. I forgot if this affected anything, but I'm gonna just try. There you go. Your app is just like physically darker. I love this darker look. And I think that the blue is kind of nice. So I'm going to keep that blue. Look at that. You have like actual nice buttons. Everything looks pretty cool. Your to-do app is not only, you know, functional. It also looks kind of nice. And I think that's just kind of cool. And I think that's everything. I think if you followed along with the tutorial, or if you're gonna do it after, whatever, I think you're done. You have a to-do app now. Isn't that cool?